When talking about data, it's vital to understand what we can do with it, and to know what we can do with different types of data, we need to understand the levels of measurement. Let's dive in. There are 4 levels of measurement: nominal, ordinal, and interval ratio. Nominal data is just categories. There's no order, no measurement. You're just talking about differences. These might be binary, as in 2, say Republicans or Democrats, or it might be multivariate, things like types of ice cream, the color of your pet, or just listing the departments here at UO. For instance, geography isn't more or less than anthropology, and anthropology isn't more or less than biology. They're just different. We can order these types of data, but we'll talk about that later. Right now, what I'm talking about here is categories. Next up, we have ordinal data. Ordinal data are ordered categories. Again, no measurements here, but there is an order. You might think about this as ratings on Yelp, or stars for restaurants, or whatever they count on Rotten Tomatoes. Ideas like ranked choice voting or ratings of how hot peppers are as fitting into this ordinal data category. For instance, we know a habanero is hotter than a jalapeno, but that's not an exact measurement. It's just hotter. Finally, we have interval and ratio data. These are both measurement data and quantitative data. There's one important difference between these, but I don't really want you to get too confused. So, for all intents and purposes for this class, you need to just think of these as one category, interval ratio. So now if you really want to know the difference between the two, interval data is when the variable does not have a true zero. This happens when we're talking about things like temperature, or things like standardized test scores. But again, I just want you to think of it as one category, but often the way I think of this is anytime I'm talking about temperature, I know I'm talking about interval data unless the data is in Kelvin, because that measurement system does have an absolute zero. Now, so what are some of the properties of these levels of measurement? We can count at all levels. We can count how many people are, say, 135 pounds. We can count all of the buildings. We can count how many 5-star restaurants there are. When talking about the mode or the median, the mode being the most common value and the median being the middle value, we can find that for all but nominal data. For instance, we can see which is the most common rating for restaurants. We can find the middle rating of all of the ratings for restaurants. We can find the most common temperature in Fahrenheit and the median temperature. Finally, we can find the most common, or say the median household income. The order is known in all but the nominal categories, but we can only quantify the difference with interval and ratio. Because ordinal data doesn't have true values, they're just an ordering, for example, good, better, and fast, we can't actually quantify that. Same goes for adding and subtracting values. We can't add or subtract a rating on a hotel, for instance. Finally, only ratio data allows us to multiply and divide. This is a little hard to grasp, and I'm not going to harp on it too much, but you can't divide or multiply interval data, because without a true zero, these numbers don't mean anything. For instance, if yesterday is 30 degrees and today is 60 degrees, you cannot say that today is twice as hot as yesterday. And then finally, only ratio data has a true zero. You can always reclassify your nominal or interval ratio data to ordinal. For instance, while flavors of ice cream are nominal, they're just categories, you can decide on an ordering system, maybe of your preferences. I would say chocolate is number 1, followed by black raspberry, rocky road, strawberry, in that order. All the way at the bottom then is plain vanilla. Who likes plain vanilla? In this graphic, here the GIS analyst is giving places that are vacant, rural, and agricultural and industrial a ranking of 4, while parks and median density residential areas are a value of 0. There's also a middle value of 2 for low density residential. You can also do this with interval and ratio data, which is pretty key for GIS work. You might want to reclassify places with median household incomes above $45,000 a year as high income and give them a 3, for instance. Places with incomes between $30,000 and $44,000 with a 2, and places below $29,000 as low income and give them a 1. It also really helps sometimes to create binary variables such as suitable or not suitable when talking about different types of land use or different elevations for a suitability analysis we'll get into later. All of those are ordinal.